Hello and welcome to today's lesson on right triangles, day 2, lesson 1. Okay, what we're looking at here today is simplifying square roots. And, we always want to look at the reason why. Being able to simplify a radical, we'll be able to work further with the Pythagorean theorem, a squared plus b squared equals c squared. Additionally, we'll be able to better approximate the length of a side of a triangle instead of relying on your calculator and a decimal approximation. Okay, and we'll use some of these rules of special right triangles. We'll need simplifying radicals to be able to help us with that. Okay, but before we begin, what we have to remember is our perfect squares. Okay, so you always want to have a perfect square table or keep these values in mind when you're simplifying radicals, because this is really your short list of values. These are the values, all of these perfect squares, 4, 9, 16, 25, 36. These are the values we're going to be looking for when we are simplifying a radical. Okay, so now if we can kind of turn this around and understand that if we square root, which is what the radical is, square root of 4 is 2, because 2 times 2 equals 4. So notice that when we're working with square roots, we're looking for the perfect square values. Okay, now we're not going to usually use all of these, but what you want to do is make sure you kind of remember the basics. If you can remember perfect squares through about 10 or 11, then you're in really good shape overall. There's just only a few that you would really miss from that point, like a 17, a 19. But if you can remember through 11, you'll be in great shape as we're working on these problems. Okay, so now, to simplify or reduce a radical, what we want to look for is look for the largest perfect square that is a factor of the radicand, okay, the number inside the radical. And what we're going to do is we always want to be able to just split this apart. So when we look at the square root of 48, the largest one, 4 pops out at us. 4 is a possibility, but it's not the largest one. The largest one is actually 16. Okay, so what we want to do is break it into 2 square roots, the square root of 16, square root of 3, and then when we finish this, okay, we've separated it into the 2 factors, each having its own radical. Okay, then we want to reduce the perfect square to finish the problem. Okay, so we have 4 square root of 3 as the solution here. Okay, the one step, if I'm looking at these steps that I left out, is under a single square root, breaking it up into the square root of 16 times 3, and then breaking it apart into the 2 radicals. Okay, so when we're looking at simplifying these, we want to go through our list. Can I divide it by 4? No. Can I divide it by 9? Yes. So I've got the square root of 9 times the square root of 3. The square root of 9 is 3. And then the square root of 3 stays because we can't do anything with it. Okay, when I'm looking at 50, okay, square root of 25 times square root of 2. Square root of 25 is 5. Square root of 2 stays under the square root. Because remember, it's only the perfect square that we can look at here. Okay, 252. Okay, 252, I'm not quite sure. So that's when I can pull out my calculator and test. 252, I bet it's divisible by 4, and it is. Gets us down to 63. That means that it's also divisible by 9. And that gets us down to 7. So sometimes when you're working with your perfect squares, you want to make sure that you take out all of them. Okay, square root of 4 times square root of 9 times square root of 7. You really want to test and make sure you're getting all of the values pulled out. Square root of 4 is 2. Square root of 9 is 3. And then the square root of 7 has to stay by itself. 2 times 3 is 6. So we get 6 square root of 7 to finish that one. Okay, now, I actually kind of showed this process in that last problem. What happens if I do not choose the largest perfect square? And in this one, I only pull out a 4. Okay, square root of 4 times square root of 12. Always check that second value and see. Go back through and test. Divide it by 4, divide it by 9, divide it by 16, divide it by 25. Okay, so you're always looking to break it up into its best pieces. Okay, and we have to get it down to a number that doesn't have a perfect square. And then we can finish up 2 times square root of 3, or 4 times square root of 3 to finish that one. Okay, 128, same thing. 128, that's where you can really start with your lower values. Now we've got 32. Oh, I can divide that by 4 again. I've got 8. I can divide that by 4 again. So in this case, I missed a couple times, but by keeping dividing, in the end, I'm always going to get to where I need to be. And then you just finish your square roots. Square root of 4 is 2, square root of 4 is 2, square root of 4 is 2, and then we've got 28. So 2 times 2 times 2 is 8, square root 2. Now, what would have been the best situation here? If I would have seen that 128 is divisible by 64 and pull out the square root of 64 first, okay, that definitely would have made the problems a little bit easier. Okay, how do I enter my answers into Schoology? So when I have 8 square root of 2, what we want to do is type in 8, SQRT, and then we put the 2 in parentheses. If it's 4 square root of 3, we want to type in the 4, SQRT, parenthesis 3. Okay, no spaces when you're entering these into Schoology. Okay, here's just some more examples. You're looking for that perfect square, pulling out as much as you can from each. Okay, notice a question like 4. Can't simplify it. Can't divide by 4, can't divide by 9, can't divide by 16. Okay, I've used up all of my options there. Okay, I can divide 18 by 9. Okay, remember, you're only using perfect squares when you divide these values out. Okay, so let's get through to... We had some additional problems here. But the one thing that we want to finish up with is multiplying values and doing some simplifying. So if I have the square root of 18 divided by the square root of 8, okay, this can be something that we can simplify down when we pull out our perfect squares. Square root of 9 times square root of 2, square root of 4 times square root of 2. Okay, so now we can simplify it down. We've got 3 square root of 2 over 2 square root of 2. And then you're just looking for values that you can cancel numerator, denominator. Canceling probably isn't the best word, but dividing out to equal 1 to finish those problems. And I know that those are some of the problems at the end of the assignment that people were struggling with a little bit. Okay, additionally, when we're looking at multiplication of values, so I can have 1/2 times the square root of 3 over 4 times 3 over square root of 2. Okay, and whenever we're multiplying, as long as there's only one piece across, we multiply the numbers, we tack the radical on the end. Multiply the numbers, tack the radical on the end, and then if there's any simplifying that we can do, we want to do that there. Okay, so that's a quick look at simplifying radicals and then solving some of our later problems in the homework. Thanks, and have a good day.